Hi guys, this is my first video and we're going to develop some perseverance and ownership by doing step-by-step chemical bonding. We're going to challenge ourselves to explore this topic, and by the time we're done we'll accomplish the long-term goal of understanding bonding. So let's get started. Well, all atoms on the periodic table are neutral and most are unstable, families 1 through 17. But unstable atoms want to bond by either losing, gaining, or sharing electrons. Unstable means that that atom does not have full energy shells. So noble gases, on the other hand, are a stable atom family because they have full outer energy shells. Well, an outer energy shell is either your first shell, which will be full at 2, and your second shell will be full at 8, and for our purposes, the third shell is full at 8 as well. All right, let's move on. Let's look at hydrogen. Is it a metal or a nonmetal? Well, we know that it's in the first family. So that's your family. It's in the first family, the alkali metal family. We also know that hydrogen is in the first period. So that's your period, first period. And this is your first family, I guess. So it has one valence electron because it's in the first family. And only because it has that one valence electron is in that family. It really belongs with the other nonmetals, which are also green like hydrogen, but it's placed over there just because of its valence electrons. To bond, you must know the valence electrons. So this is a little different chart of the periodic table where it's showing you the Lewis or electron dot diagrams for all the elements except the transition metals and any of the rare earth elements. So as you can see, every number we can label above up to 8 above each family. These numbers 1 through 8 represent the number of valence electrons. The exception is helium, where it only has 2 valence electrons in its full because it's in the first period with hydrogen. So it's in period 1. It has 2 electrons in your full. Lithium to neon are in period 2. They have 8 electrons in their full. Sodium to argon are in the third period, and they have 8 electrons in their full for our purposes. So now let's look at how many valence electrons does oxygen have. Well, oxygen on the periodic table has an atomic number of 8. So that means that it has 8 protons, 8 neutrons, because I know the mass is 16 as well, and 8 total electrons. So of those 8 electrons, the nucleus, we're not going to put the protons and neutrons, we'll just draw it as a black circle. We're going to do the Bohr diagram now. So how many go in the first shell? So 2 electrons go in the first shell, and how many go in the second shell? Well, if you take 8, subtract 2, 6 are left over, so there's 6 valence electrons. And that also matches this up here. Okay, let's go. Another quick review about periods. Every period row represents a new shell. The element's period number corresponds to the number of shells. So to bond, you need to know how many electrons to fill each energy shell. So let's look at hydrogen. Hydrogen is in the first period, which is the first row, and it only needs 2 valence electrons and it's full. Lithium to neon is in this second period, and they need 8 valence electrons to be a full shell. So they're always looking to be filled at 8. Where sodium to argon are in the third period, and for our purposes, 8 is full there as well. So we're always looking, if you're an element, to be full. What does it need to be full? The first period only has 2 elements, hydrogen and helium, and only 2 electrons are required to have a full shell. The second period has 8 elements, and 8 electrons are needed to fill the second shell. The third period also has 8 elements and has 18 electrons for the shell. But in chemistry, you will learn more how shells are filled. But for our class, the third shell is filled with just 8 electrons. So here you are again, 2 for the first shell, 8 for the second shell. And the third shell can have 18 electrons, but for our purposes, 8 is full. How do atoms bond? Metals lose electrons. Another word for lose is transfer. Nonmetals can either gain electrons or they can share electrons. So let's look at our metals first. Our metals are our losers. All this areas are losers. So these guys are the losers. They're going to lose electrons to nonmetals. So nonmetals are going to gain the electrons from the metals. So they are your gainers. So metals lose, nonmetals gain electrons. That will make ionic bonds. Nonmetals can also share electrons. So for example, water and carbon dioxide are examples of sharing electrons. That's two nonmetals bonding together. Hydrogen's a nonmetal, remember, even because it's over here, it's still a nonmetal. Okay. Now that we've finished the introduction, we're ready for our step-by-step guide to ionic and covalent bonding. Well, here's two examples of two types of bonds. So on the left-hand side, you have covalent or sharing electrons. So atom 1 is sharing with atom 2, and you're making a molecule. And they're sharing those electrons right in this area. In ionic bonding, atom 3 is losing electrons to atom 4, and atom 4 is gaining electrons. Therefore, you're making an ionic bond. The electrons, you notice in the compound, are on one side, making it a negative ion. And the other one who loses the electrons is a positive ion. Let's look at ionic bonding, which is a transfer of electrons. You can either lose or gain electrons for an atom. So here's our example of a simple ionic bond where atoms are losing and atoms are gaining electrons. In covalent bonds, you are sharing electrons. Ionic bonding is when atoms lose or gain electrons. So we're going to have 4 major steps. The first step is to determine the number of valence electrons for each atom. Valence electrons are the outermost shell electrons, and they're involved in bonding. So now we're going to draw the Lewis dot diagram around the chemical symbol. No more than 2 valence electrons per side. So sodium has atomic number of 11, therefore it has 11 protons. And because it's neutral on the periodic table, 11 protons will equal 11 electrons. Now, we're really interested in the number of valence electrons. So we look at the shells. It has 3 orbital shells because it's in the third period. It has 2 electrons in the first shell. It has 8 in the second shell. So 2 plus 8 is 10. So it has 1 in the third shell. 2 plus 8 plus 1 equals 11 total electrons. And one of those will be a valence electron. Sodium is an alkali metal. All alkali metals have 1 valence electron. So what does sodium need to do to be happy or full? Well, it's a metal, so it's going to lose that 1 valence electron. Chlorine has 17 protons and 17 electrons. It is neutral on the periodic table, so protons equal electrons. It has 7 valence electrons. How did you get 7? Well, you can either look at your halogen family and notice that 7 is on top, or you can notice that 2 are in the first shell, 8 are in the second shell, and 7 are in the third shell. So 1, 2, 3, 4, 5, 6, 7. So 2 plus 8 plus 7 equals 17. So 7 valence electrons. Hence, 7 dots around the chemical symbol. Chlorine only needs 1 more valence electron to be full. So, now we're going to start bonding sodium and chlorine. We first looked if the atom is a metal. If it's a metal, it's a loser of electrons. We note if the atom is a nonmetal. If it's a nonmetal, it's a gainer of electrons. So you're going to draw an arrow in step 2 from the loser to the gainer of electrons, just like sodium is doing right here. So sodium will lose that one valence electron, and chlorine will gain that one valence electron. So we're going to recap what we just did in step 2. All atoms want to have their outer electron shell filled. A sodium atom, or any atom, is neutral on the periodic table because the number of protons equal the number of electrons. But sodium would be happier to lose one electron in its outer shell by transferring that electron or losing that electron to chlorine. Chlorine has 7 valence electrons, and by gaining one more electron, it will have 8 in its outer shell. Therefore, it is now full and happy. Here is a great picture to show you how sodium goes down to 2 shells versus 3 it used to have. So sodium loses an electron to chlorine, and when it does that, it loses that third shell. It now has only 2 energy shells full of 8 valence electrons in that second shell, and chlorine has 3 energy shells with 8 valence electrons in its third shell. So both atoms are now stable and happy. Sodium has 11 electrons before bonding, 11 negative charges. And now, after bonding, has 10 electrons because it lost an electron. So now we compare the 10 electrons to the 11 protons, or positive charges, and we ask ourselves, what do we have more of? Do we have more positive charges or negative charges? So we have 11 positive charges versus 10 negative charges, so positive charges are winning by 1. So we have 1 less electron, or a +1 or 1 plus ion. Sodium lost an electron, therefore it is more positively charged. Chlorine gained an electron, therefore it is more negatively charged. The number corresponds to how many electrons are transferred for each atom. Now let's look at chlorine. Chlorine had 17 electrons before bonding. Chlorine gained an electron from sodium, therefore now it has 18 electrons, which are negative, and you compare that to the 17 protons that it has that are positive. So you ask yourself, who do we have more of, or who's winning? And it's a chlorine ion has a negative charge. We have 1 more electron. So -1 or 1 minus. Sodium lost an electron, therefore it is more positively charged. Chlorine gained an electron, therefore it is more negatively charged. And remember, the number corresponds to how many electrons are transferred for each atom. Now we are ready for step 3. We have to determine the charge for each atom. The loser of electrons is a positive ion. Write it like that as well. The gainer of electrons is a negative ion. In this example, we only have 1 atom of sodium and 1 atom of chlorine. In other examples, you can have multiple atoms. So remember, it's the charge per atom. We're on the final step 4 for ionic bonding. We're going to write the new chemical formula, or the neutral compound, which is just NaCl without the charges, because the charges for each ion should balance each other out. So the +1 charge for sodium balances out with a -1 charge for chlorine to become a neutral compound. Here is an example of sodium and chlorine bonding. Sodium is losing its electron to chlorine. Chlorine's gaining the electron down here. Therefore, you made sodium chloride. Notice that you have a positive ion for sodium because it lost an electron. Chlorine has a negative ion because it gained an electron. And when you balance them out, it's just a neutral compound of sodium chloride, or NaCl. Okay, now we're going to get a little more difficult. We're going to do ionic bonding with more than 2 atoms. Consider what happens when magnesium reacts with chlorine. Magnesium, a metal, has 2 valence electrons in its outer shell. So it's going to want to lose 2 electrons to be happy, because it is an alkaline earth metal, and alkaline earth metals have 2 valence electrons. Or you can look at the diagram here and see that there's 1 here one here, or 2 valence electrons. Magnesium wants to lose 2 electrons, but each chlorine atom only needs 1 more electron to be filled. If you remember, chlorine has 7 valence electrons, so it needs only 1 more electron to be filled. So if magnesium needs to lose 2, only 1's going to go to chlorine. So we have a little problem here. What's going to happen to the other electron that magnesium needs to lose? Let's find out. So we're going to start with step 1. Step 1 is to draw the Lewis dot for your valence electrons. Magnesium has 2 valence electrons, so I'm putting 2 dots next to magnesium. And chlorine has 7 valence electrons, so I'm putting 7 dots around the chemical symbol of chlorine. Okay, we're on step 2. We're going to draw arrows from the loser to the gainer. Magnesium is a metal, so it's a loser. It's going to lose 2 electrons. One of them is going to go to this atom of chlorine. So this atom of chlorine is now full with 8. And so then you ask yourselves, what does magnesium need to get rid of that other valence electron? Well, it needs another atom of chlorine. So here, hence, we give the other valence electron to another atom of chlorine. So here's a picture of what we just did. Magnesium, by losing its electrons to chlorine, becomes a 2 positive or positively charged ion by 2, or 2 plus. Chlorine, on the other hand, is a negatively charged ion. -1, or just a minus, they drop the 1 for that atom, and the same for this atom. Because remember, each atom gained only 1 electron. It's charge per atom. Here's another picture down below, and you can see that each chlorine atom gained 1 electron, so it's negatively charged, or -1 charge, where each atom of magnesium, which is only 1 in this case, has a 2 positive charge, or 2 plus. So here's step 3, where we're determining the charge for each atom. Magnesium has a 2 plus charge, and we have 2 atoms of chlorine, each with a 1 minus charge. Now when you add them together, because you have 2 atoms of chlorine, the way you would write it would be Cl2 subscript 2, meaning 2 atoms of chlorine, each with a 1 minus charge. We're on the final step 4 for ionic bonding. We're going to write the new chemical formula, MgCl2. Mg, to refresh your memory, was a positive ion, positive 2 ion. Chlorine, each atom of chlorine is a -1 ion. So you had 2 of them, which equals a -2. And those charges for each atom will balance each other out to make a neutral compound, MgCl2. I'm so proud of you. You've listened to this whole presentation. You persevered. You'll take ownership of this bonding activity, and hopefully bonding will be something you're successful at. So let's just wrap it up. Ionic bonds. Sodium chloride. It's in 2 different places. Sodium is a positive ion because it loses an electron, goes down to 2 shells. Sodium is a metal, it's a loser. Chlorine, a nonmetal, will gain the electron from sodium. It will be more negatively charged ion, and when they get together, they make sodium chloride or salt. Oxygen is covalently bonded. 2 oxygen atoms are both nonmetals. 2 nonmetals bonded together share the electrons. Here's an example of hydrogen. 2 atoms of hydrogen sharing electrons, making hydrogen gas. Congratulations, you did it.